There is a place on Earth where light has been extinct for 200 million years, where the pressure would crush a human skull in less than a second, where the temperature hovers just above freezing, and the silence is so absolute that sound itself seems to disappear into the void. And yet, in this graveyard of light, something glows. Not the blue-green bioluminescence you might expect, not the ghostly shimmer of jellyfish or the constellation of lanternfish that drift through the midnight zone like living stars. No, this light is red, blood red, and almost nothing down there can see it, except the creature that makes it. Welcome to the hunting ground of the dragonfish, one of the ocean's most sophisticated predators. And what it does with light shouldn't be possible. To understand why red light in the deep sea is so extraordinary, you need to understand what happened to color itself. Sunlight, the full spectrum we see on the surface, begins to die the moment it touches the ocean. Red wavelengths are the first to go. Within just 15 feet of the surface, red light is completely absorbed by water molecules. It simply ceases to exist. Orange follows, then yellow, then green. By the time you descend 600 feet, past the edge of the twilight zone, only the faintest traces of blue remain, a dim, directionless glow that barely qualifies as light. And then, nothing. Beyond 1,000 feet, you enter the midnight zone, perpetual darkness. A three-dimensional void that stretches for thousands of miles in every direction. Down here, the concept of daytime is meaningless. There are no sunrises, no seasons, no shadows. Evolution erased red from this world 200 million years ago, and yet the dragonfish brought it back. The question is why? Most bioluminescent creatures in the deep sea produce blue or green light, wavelengths that travel well through water and match the faint downwelling light from the surface. They use this light to communicate, to attract mates, to confuse predators. Some, like the anglerfish, use glowing lures to draw prey close enough to strike. But blue-green light has a fatal flaw. Everyone can see it. When you glow in the deep sea, you're not just a beacon to your prey, you're a beacon to everything. Every predator, every scavenger, every opportunistic hunter drifting through the dark. You become visible in a world where visibility is death. The dragonfish found a way around this. Beneath its eyes, small subdermal organs called photophores, it produces red bioluminescence, a wavelength that, by all logic, should not exist at these depths. And here's the key. Almost nothing in the deep ocean can see red light. Most deep-sea creatures have lost the ability to perceive red wavelengths entirely. Their eyes are adapted only to detect blue and green, the only colors that penetrate this deep. To them, red light is invisible. Pause, imagine that. Imagine being able to shine a flashlight that only you can see. You illuminate your prey. You track their movements in perfect detail. You close in with absolute precision. And they never know you're there until it's too late. So how did the dragonfish evolve this ability? The answer lies in one of evolution's strangest coincidences, a convergence so unlikely that scientists are still piecing together how it happened. Most bioluminescence in the ocean is produced through a chemical reaction. A molecule called luciferin combines with oxygen, in the presence of an enzyme called luciferase, producing light. But the dragonfish doesn't just produce light, it produces red light. And to do that, it had to modify the chemistry entirely. Inside its photophores, the dragonfish uses a form of chlorophyll, the same molecule that makes plants green, to shift the wavelength from blue to red. This is not a common evolutionary pathway, in fact it's almost unheard of. Chlorophyll-based red bioluminescence has only been confirmed in a handful of species, and scientists still don't fully understand it. Some believe it may have originated from symbiotic bacteria. Others think it could be the result of horizontal gene transfer, where genes are passed between organisms that aren't parent and offspring. Whatever the origin, the result is the same. The dragonfish evolved a private wavelength, a color that exists only for it. But the story doesn't end there, because producing red light is only half the equation. To hunt with it, the dragonfish also had to evolve the ability to see it. Here's where things get truly strange. The dragonfish doesn't just have red photophores, it also has red sensitive vision, an adaptation so rare in the deep sea that most species simply don't possess it. Its retinas contain specialized photopigments that can detect long wavelengths of light, wavelengths that, to almost every other creature down there, do not exist. Think about what this means. The dragonfish exists in a sensory dimension that nothing else can access. It's like having night vision goggles in a world where everyone else is blind. But there's a cost. To maintain red-sensitive vision, the dragonfish sacrifices something critical: sensitivity to blue-green light. Its eyes are essentially tuned to a wavelength that barely exists in nature, which means it relies almost entirely on its own bioluminescence to see. If it didn't produce red light, it would be functionally blind. Pause. This is one of evolution's most dangerous gambits. The dragonfish has locked itself into a biological arms race with its own physiology. It must produce red light to hunt. It must see red light to survive. And if either system fails, it dies. Scientists still don't know how much energy this system requires, or how the dragonfish balances the metabolic cost of producing light. With the need to hunt in one of the most food-scarce environments on the planet, what we do know is this: the dragonfish didn't just adapt to the deep sea, it rewrote the rules. But here's the question that keeps scientists awake at night. What if the dragonfish isn't alone? Red bioluminescence has been confirmed in only a few species, but the deep ocean is the largest and least explored ecosystem on Earth. We've mapped less than 5% of the ocean floor. We've explored even less of the water column. Every year, researchers discover new species of deep-sea life, creatures with adaptations we didn't think were possible. And every year they find evidence that evolution in the deep sea is far more sophisticated than we imagined. So the question isn't just, why did the dragonfish evolve red light? The question is, what else is down there that we can't see? What other private wavelengths exist in the darkness? What other sensory dimensions have evolved beyond our ability to detect them? The dragonfish is a reminder that nature is not bound by our assumptions, that the absence of light does not mean the absence of vision, that in the deepest, darkest corners of the planet, life finds ways to communicate, to hunt, to survive, in languages we are only beginning to understand. There is something profoundly unsettling about the dragonfish, not because it's monstrous, though it is, not because it hunts in total darkness, though it does, but because it exists in a world that we cannot fully perceive, a world where color is a weapon, where light is a secret, where evolution has carved out private realities that overlap with ours, but remain forever separate. We like to think we understand the ocean, that we've cataloged its creatures, mapped its depths, decoded its mysteries. But the truth is we're still strangers here. The dragonfish is proof of that. It's a reminder that the ocean doesn't need us to understand it, that it has been running its own experiments, its own evolutionary arms races for hundreds of millions of years. And we've only just started looking. So the next time you think about the deep sea, remember this. There are lights down there that you will never see, colors that exist only for the creatures that produce them, and predators that hunt in wavelengths we didn't even know were possible. The dragonfish brought red light back from extinction, not for us, for itself. And that is what makes it terrifying.